All right, Matt 2, here we go. We got 9-4 special cases, binomial patterns. So we're going to be multiplying binomials again, but what we're going to hope to see is that certain problems have a pattern to it, and then we're going to try to learn that pattern so that those types of problems go faster. Now, most of these patterns you don't have to know. You can rely back on your multiplying binomials and do that, and it's not going to affect anything. Now, one of these patterns you're going to really want to know because we're going to have to do some factoring later on. We're going to have to factor this stuff like we did on Monday. And it's going to be really important that you see that pattern. Anyways, explain why x minus 5 squared, okay, is not equivalent to x squared plus 25, and it's not equivalent to x squared minus 25. Now, a lot of you look at it and go, wait, how is it not equal to that? Well, there's a reason for that. So over here, I've got a binomial sum squared. So my binomial is a plus b, and I'm going to square it. Now my answer is a squared plus 2ab plus b squared. Notice I did not write a squared plus b squared. That is not what this is squared. And some of you are thinking, well, isn't that what we just did in that last unit? Didn't I just square this and square that? Well, remember last unit, these were all monomials. They were single terms. This is a binomial. What you did last unit doesn't work for binomials. And it's really easy to see why. Because a plus b squared is supposed to be a plus b times a plus b. Right? These two are the same thing. A plus b squared equals a plus b times a plus b. Yeah, it does. So what we can do for this is show the area model real fast to show that we're going to get this answer up here. So if I put a and b here and a and b here, here I get a squared, I get ab here, and b squared here. And notice what you would have been missing if you wrote a squared, b squared. You would have been missing this 2ab. See, I got two of these ab's in the middle. So what I'm going to do now is show you a shortcut for doing these types of problems. Now, a lot of people don't understand the shortcut, and if you don't understand it, that's fine. Your job will be to break it up like this and then do the area model. So here's the shortcut. The first term is this number squared. The second term is 2 times this number and this number. The last term is this number squared. So let's look at that. Here's the first number. Okay, so we're going to say that A is B, and the second number is 13. So I'm supposed to take A squared, so that's this one squared, B squared. Then I'm supposed to take 2 times A times B. 2 times B times 13. Well, B times 13 is 13B. So 2 times 13B is what we put in the middle one. That's 26B. And then the last number would be 13 squared. See, here's the pattern. I take the first one, square it. The middle one is this one times this one times 2. And then the last number is b squared. So what do I get? I get b squared plus 26b, and 13 times 13 is 169. And there's my answer. Now, if you don't get that pattern, that's fine. What you would have done is the area model. You would have said, okay, b plus 13 squared is b plus 13 times b plus 13. So then you would have done your little area model over here, b and 13, b and 13. You would have gotten b squared, 13b, 13b, and 169. And then these 13b's are where I'm getting my 26b from. So getting the same way, just a different way to do it. Okay, so for the next one, let's do the shortcut real fast. T times t, because this is the first term squared, so that's going to be t squared. So I'm taking the first number and squaring it, and then I'm going to do plus 2 times t times 9. 2 times a times b, so 2 times t times 9. And then we're going to do plus 9 squared, the last number squared in the pattern. So this one right here gives me t squared. 2 times t times 9 is 18t. And then 9 squared is 81. And there we have our answer. And we can double check it by doing the area model. So if I did the area model, t plus 9 and t plus 9, we get t squared, 9t, 9t, 81. And here's our two 9t's that make the 18t that goes in the middle. This is why it's 2 times t plus 9. Okay, so this one, I'm going to do 7x squared because it's the first term squared. And then I'm going to do plus 2 times 7x times 5, because this is 2 times a times b. And then we're going to do plus 5 squared at the end. So 7x times 7x, that's 49x squared. 2 times 7 times 5. Well, 7 times 5 is 35, and 35 times 2 is 70, so this is plus 70x. And then 5 times 5 is 25. There we go, got our answer. And when you do a lot of these, you actually can do these all in your head. Again, if you wanted to do the area model instead, I'm not going to judge you. That works. Some people just don't see that pattern, and that's fine. You'll eventually see it, but you just don't see it right away. That's fine. Just do your area model where you do 7x plus 5 times 7x plus 5. So we know that this is just 7x plus 5 times 7x plus 5. So we get 49x squared here, 35x here, 35x here, and 25 here. And this is where I'm getting that 70x from that's in the middle there. All right, so that's what happens if you have a sum that's being squared. So we've got a binomial, and we're adding, and it's being squared. So that's the pattern. We have a slightly different pattern here when it's a binomial difference squared. Binomial difference squared means we're subtracting this time. So the only thing that's different is that this middle term has a negative out front instead of having a positive. So if I were to do this one, I'd say, okay, the first term is squared, and then I do negative 2 times a is x, and then times b, which is 2y. Notice I didn't put the negative with it. That's what you're supposed to do because it's just 2y is the b. This is the a value. This is the b value. And we don't look at the negative in between them. Okay, and then on the last term, I'm going to take 2y squared. So x squared is x squared. Negative 2 times x times 2y is negative 4xy. 2y times 2y is 4y squared. And there's our answer. Again, you can split this up into x minus 2y times x minus 2y. And you'll get the same answer that I was just worked out right here if you do the area model. I'll do it real fast since this isn't taking too long. So we got x minus 2y, x minus 2y. So I got x squared, negative 2xy, negative 2xy, and positive 4y squared. And here's where I'm getting this negative 4xy from, because I've got negative 2xy and negative 2xy. Next one, so I would take 3a and square it, and then I'm going to multiply 3a and 7b times negative 2, because it's the pattern says negative 2 times a times b. Remember, this is a and this is b. Okay, and then the last part of the pattern is to square that 7b. So 3a times 3a is 9a squared. 2 times 3 is 6, times 7 is 42, so this is minus 42ab. And then 7b times 7b is 49b squared. So using the pattern where I square the first term, I multiply these two terms, and then multiply by -2, and lastly I square that 7b at the end. And again, if you like, you can do your area model. You got 3a minus 7b and 3a minus 7b. So this is 9a squared. This is negative 21b, ab, dang it, and negative 21ab, and positive 49b squared. These two terms right here are where I'm getting the negative 42ab from, because it's 21ab and 21ab. All right, we are almost there. 3 more problems. All right, the last thing we're going to look at is the product of a binomial sum and a difference. So this is a plus b times a minus b. We're always going to get a squared minus b squared when this happens. And let's just show to see what that happens here. So this is the one that you really need to remember for later on when we start factoring this. So if I multiply a plus b times a minus b, I get a squared here. Here I get ab, and here I get negative ab. So what's happening is these two are canceling each other out because they're opposites. And here I get negative b squared. So it's a squared minus b squared because these two terms always cancel each other. So I get a squared minus b squared. All right, so this one is x minus 10 times x plus 10. So this is our a and this is our b. So this is a minus b, a plus b. So I'm going to take the x and square it. And then I'm going to take the b and square that. So x squared and then 10 times 10 is 100. We get x squared minus 100. And we can see that that works when we set up our area model. We got x minus 10 here and x plus 10 here, x squared, negative 10x, positive 10x. So those cancel each other, and then negative 100 down here. So since these cancel, I got x squared minus 100 is my final answer. So for this one, I would just do 7x squared squared minus 9y to the third squared. So 7x squared squared is 49x to the fourth. 9 squared is 81, and y to the third raised to the second is y to the sixth. 6, not second, y to the 2. All right, 81y to the sixth. If you don't believe me, do the area model. All right, next one. We're going to find the area of the shaded region. So this shaded region is this yellow one here. So this looks like a square since it's x plus 9 and x plus 9. So how are we going to find the area of just the yellow section when we've got this section, it looks like that's been cut out? So it looks like if we take the area of the entire shape and then subtract this little area right here, that should be the area of the shaded region. So here's what I'm going to do. I'm going to take x plus 9 squared, and then I'm going to subtract this shaded region, or this non-shaded part, this little hole. I'm going to subtract x minus 1. So this is the big square, and I'm going to subtract out the area of this little cutout portion, and that should be my answer. So remember our patterns here. So our pattern for this one, we would take x, square it, plus 2 times x plus 9, times 9. and then I'd square the 9. Because that's a binomial sum. All right, so let's do that one first. That gives me x squared plus 18x, and then plus 81. All right, that's x plus 9 squared. Next, let's do this one. So I'm going to do x squared, and then I'm going to do, since this is a binomial difference squared, this is minus 2 times x times 1. And then it's going to be plus 1 squared. So this one gives me x squared minus 2x plus 1. Okay, so x minus 1 times x minus 1 is x squared minus 2x plus 1. Okay, now I have to subtract these, which means I have to distribute this negative to all three of these. And this is where a lot of people are going to make a mistake. They're going to forget to distribute that negative. So when I distribute that negative, I get negative x squared, positive 2x, and negative 1. So now I'll combine my like terms. I've got an x squared and a negative x squared. Those cancel each other out. I've got an 18x and I've got a positive 2x. Together, those make 20x. I've got an 81 and a negative 1. That's going to be a total of 80. And now we are done. All right, don't forget to answer the question. Explain why x minus 5 squared is not x squared plus 25, and it's not x squared plus 25 or minus 25. It's neither one of those. So remember, you can split it up and then use your area model, or you can start using these patterns. It's up to you how you want to do that. All right, Math Hard, I will see you later. Bye-bye.